Hello and welcome once again to another slide video from the Cornish Radio Amateur Club, and today we're going to look at using the calculator, specifically the Texas Instrument TI-30Xa. Now this is the first of two parts. It's quite a long one. It goes through most of the buttons on the TI-30A, TI-30Xa. And you may want to skip this video if you're already familiar with using a scientific calculator. And although it's fairly long, there will be a subsequent video, part 2, which will look at what we've learnt in part 1, but applying those to some of the formulas that are on the formula sheet that you will be supplied in the Advanced Certificate examination. So, here we go. So let's look at the Texas Instrument TI-30Xa. Before we start, I would say that it's not important, not too important, which type of calculator you choose, or which model of calculator you choose, as long as you're happy with it, familiar with it, and able to drive it when you come to the exam. There are two types of calculator, or two basic flavors that you tend to encounter. The first could be the type that is illustrated in the RSGB book Advance, the Casio there, and for which they have an instructional film, which I think is meant to be very good. I haven't seen it myself, but that type of calculator is what I would call an algebraic entry calculator, in as much as you tend to put the values in the same order and in the same format as the equation. So it's got the advantage that you can see on a multi-line display what the equation looks like, and you can go back and you can see if you've made any errors before you press equals and get the answer. So that's quite good. The disadvantage is that it tends to be a little bit cumbersome to do the data entry. And the second type of calculator is the type that we'll be looking at today, where you tend to enter in various components of the equation and get intermediate results by pressing the function keys and then manipulating those. Now, it sounds more complicated, but in fact, a lot of people find it a bit simpler. So anyway, as I say, it doesn't really matter. Some people can quite comfortably chop and change between them. Others get a strong preference for a different type. So we'll have a look at the second type today, and we'll go through the operation of the TI-30Xa in as much as it affects us in doing the RSGB Advanced Certificate. We won't be touching on all of the functions of the calculator because we don't need to be able to use all of the functions. Where there is a function, I will perhaps just talk about it briefly to demystify it, but I'll identify it as one that probably isn't needed. Well, the first thing, obviously, to be able to do is to switch on the calculator. And top right, there's an on-off switch. Make sure for the exam you have a good battery in the calculator, because you don't want that going wrong. The second thing to say about it is that there is an off switch, and when you press the on switch, it's an on cancel switch. When you press that on, it'll clear any previous results. Now, if you switch it on after it's been switched off, you will see degree, or DEG, on the display, and that's the mode you want to be in. There are different ways of measuring angles. The type of angle that this calculator supports is either degrees, radians, or gradient. Degrees and radians are used fairly commonly, but I don't think there are any calculations that we need to worry about that take into account any angular measurement that we need to come up with an answer for. So just to demystify that then, I think we can say this, that if we have a circle looking like this, not a very good circle, we know that this is divided into 360 degrees. And indeed, if the calculator is set to degrees, and we enter in 2, and then take the sine of it, or some angular measurement, it'll assume that we mean 2 degrees. There's another way of measuring an angle, and that is, if we have a circle, I'm going to draw a slightly larger one, and we have the radius of the circle, and then we measure at an equal distance to the radius along the arc of the circle, and then we come back, then that angle there is now 1 radian. And that's one of the other modes. Now you can switch between degrees, radians, and gradient by repeatedly pressing the button there, DRG, degrees, radian, and gradient. So if you were in radians and you typed in 2, then it would assume that it would be 2 radians. Now 1 radian is a number close to 57 degrees, and there are 2 pi radians in a circle, in a complete circle. So as I say, that's just to demystify it, and I don't think that we need to worry about that at all. But as I say, when you come from off to on, it'll be in degrees anyway, and so that's fine. The next thing you may notice after you switch it on are M1, M2 and M3 in the top of the display. This calculator supports 3 memories. Now, to load a value into a memory, let's say 45, type 45 into the calculator, and use the store button, and press store, and then 1 for memory 1. And then you will see at the top left of the display, up here, you will see M1. So the keystrokes for that were 45, and then store, and then memory, store, and then 1. Now, we know that we've got 45 stored in memory 1, and if we press all clear, and we press recall 1, 45 comes back into the display. So the thing to remember about the memories are that they're not cleared using the clear button. The clear button only clears the display. If I put in 22, and I store that in 2, I press clear, I can say recall 1 plus recall 2 equals, and I've got 67. So let's have a look at those keystrokes again. I put 22. Oops, I put 2. Store in 2. Okay. And so hidden in the calculator in memory 1, I've got 45. And in memory 2, I've got 22. And I can access those memories using the recall button. So, for example, if I say recall 1 plus recall 2, sorry about that, 2, and then I press equals, then on the display I will have 67, which is the 45 plus the 22. So the memories are quite useful for storing interim results. And remember that they're not cleared by pressing the on clear button. Now that we've got 67 in there, and we've got memory 1 and then memory 2 there, if you look at the display on your calculator, you will see M1 and M2 in the top left of the display, indicating that there are values in memory 1 and memory 2. There isn't a value in memory 3. Memory 3 is still empty. So how do we clear a memory? Well, we can simply overwrite it. We don't need to clear it. For example, I could say 11 store 1, and then if I say recall 1 plus recall 2 equals, I get 33, because I've replaced the 45 with 11, and 11 plus 22 will give me, in my display, 33. But if I want to clear the memory, I do that by storing 0 in the memory. So if I type 0 into my display, and then store 1, like 2 strokes down here, put in 0, store 1, then you will see that the memory 1 light, or memory 1 annunciator, is extinguished, indicating that there's no value at all in memory 1. And similarly, I can put in 0, store 2, and that will clear memory 2. So you can use the memories for storing interim results, and quite often it can be quite useful just to use them for temporary storage. But most of the equations that we come across, we can get by using the brackets. And the brackets are here and here, and we'll come into doing that later on. So we've talked about degrees radians. The next button, as we move across, is the log button. Now we will be using logarithms for dBs, and we'll be having a look at the formula for that in just a second. The opposite of log is anti-log, or 10 to the x. The important thing to remember about logarithms is that they are indices. The next button along, ln, are natural logs. There's a video covering natural logs and decibels. We won't be using natural logs at all in this advanced certificate, so you do not need to worry about this button here. The off button we've covered, it just simply switches the calculator off and the calculator comes back on with the on button. This button here, HYP, hyperbolic, this is for trigonometry, and we won't be using that. Neither will we be using sine, cos or tan or their inverse functions. This button here, y to the x, we may well use. And to access, by the way, I didn't mention, to access the green functions, ones above, you press the second function key here. So y to the x is, for example, if we put in 2, y to the x 2 equals, it gives us 4. If we enter 2, y to the x 3 equals, it gives us 8. Let's just see what we've done there. That's the y to the x button. If we want to find 2 squared, okay, we type in 2 into the display. The display is, if you like, the x variable on the calculator. So when we then press, after 2, we press the y to the x button, that 2, if you like, is moved upwards and becomes invisible, but is still there. And then if we replace the 2 here with another 2, that gives us, that's now, this one becomes a y, so that becomes 2 to the power 2, which is equal to 4. You can try it again. You can try by putting in 2 y to the x 3 equals, and the calculation you've done is 2 to the power 3. In other words, you've done 2 times 2 times 2, which is equal to 8. So let's have a look at that then. So if we press clear and we say 2 y to the x 3, we indeed do get 8. So remember, anything to a power something is not 2 times 3, which of course is 6. It's 2 times 2 times 2. In other words, 2 times itself, 3 times, which is 8. Let's have a look at another one. 10 times 10. We can write that as 10 squared. And we know the answer is 100. So if we put in 10, y to the x 2, we do indeed get 100. So that was 10 keystrokes now. Y to the x 2 equals 100. So that's a fairly useful key to have. Now the key that's accessible above y to the x is the key that says x root y. It looks like this, the xth root of y. So you would use that key, for example, to find the square root of 4. Now we know what the square root of 4 is. 2 times 2 is 4, so the square root of 4 is equal to 2. So let's have a quick look and see how that works out on the calculator. All clear? So now we type in 4, second function, x root y, 2 equals, and the answer is 2. So the keystrokes for that were 4 in the second function, which gave us access to x root y, then 2, and that, after we press the equal sign, gave us 2. So let's find out what the square root of 100 is. Well, we know that 10 tens are 100. Let's find out the square root of 100. So going to the calculator, press the all clear, the clear button, and we press in 100. Second function, x root of y, 2 equals, and it gives us 10. So going through those keystrokes again, we type in 100, second function, x root of y, 2, and it gave us, after we press the equal sign, 10. So for the moment we've just used it for square root, but we could also use it for cube root. If we wanted to know, for example, what the cube root of 8 was, well, we know it's 2. So what we're writing down is we're saying the cube root of 8. Well, 8 equals 2 times 2 times 2. In other words, 2 cubed is 8, or the cube root of 8 is 2. So the answer then is going to be 2. Let's do it on the calculator. We press the clear button, we type in 8, second function, x root y, 2, I beg your pardon, that should have been a 3, so I'll start again with that one. We type in 8, second function, x root y, 3 equals, and the answer is 2. So the keystrokes again for that are, after pressing clear, 8, second function, x root of y, 2 equals, and it gives us 2. So that button there then either gives us something to the power something, or the something root of something. So quite a useful one to have. So I think it's quite important now to think a little bit about what's happening actually in the calculator. The next button gives us a bit of a clue. The pi button, well, that's fairly self-explanatory. If we press that, it gives us the value of pi. By the way, we do need that in some of the formulae that we use. But actually thinking about how the calculator works, you have to imagine it, if you like, as the screen being X. And when you use one of the function keys, as you press it, it pushes a copy of what's in the screen up to an invisible area, another screen if you like, one that you can't see though, if that makes sense, called Y. So in the previous example, when we were saying the xth root of Y, we were pressing in the value for Y first of all, for example 100. And then we would press the second function x root y, and that would create another copy up here. And then we would type in 2 to replace the 100 here. So that when we have the formula x root of y, we're saying the second root of 100. And at that point, in this register, as it's called, we have 2, and in this register here, we have 100. So this next button allows us to swap them over. Let's go through an example of doing that. Press all clear. Let's find the square root of 100. We put in 100, and that is now sitting, if you like, in this register here, the x root. We press second function, x root y. Our 100 has now moved up, or copied up, and is now sitting in there. We press 2, and then equals. Well, first of all, we press 2 before I press equals. Now we have 2 in the x and in the y. 100 in the y and 2 in the x. Now when I press equals, I get the answer, which is 10. So now in the x, I've got 10. If I press second function x to y, I get 2, because the 10 going in here has pushed these registers further up. So now we have the 100 here, we have the 10 here, and pressing the second function, swap x with y, and swap the 10 and the 2, and so now we have 2 in the display. If I press it again, it swaps them back, and now I've got the 10 in the display. Now this isn't a button that you need to use. It's handy if you get used to it, but it really is not necessary for the advanced certificate. But what I'm trying to illustrate to you here is that as you go through the calculations on the calculator, the main display is the X display, whatever the number in there is the X display. There is another display above it called Y, and as you put your calculations in, things tend to move up and up to extra registers. So the word register and display are interchangeable in this context. But don't worry too much about that. If that seems a little bit obscure and difficult, then don't worry about it. You won't need to be able to do that or understand it for the advanced certificate. but it gives you an insight into what's happening in the calculator, which can be helpful. So going back again, we've said that we've got the pi key there, and we will be using the pi key quite a lot in our calculations. And if you press it at any time, in the X display, or in the display, you will see 3.14159, which is, to, I don't know how many significant figures, a reasonable approximation for pi. The next button along is, we didn't finish the previous row. I think perhaps we said sine, cos and tan are not required. We did do that. That was pi. The next one across is 1 over x, and that's the button you find you'll be using a lot. That's the 1 over x button, or the reciprocal button. So let's have a look at some reciprocals. The reciprocal of 1 is 1 over 1, which is 1. The reciprocal of 2, okay, is 1 over 2, which is equal to a half. And the reciprocal of 3 is 1 over 3, which is equal to a third. If we go back the other way, the reciprocal of a half, okay, is 1 over a half, which you could write as 1 over 0.5. And how many 0.5s in that is 2. So, going back the other way, the reciprocal of a half is 2, and the reciprocal of a third is 3. So, taking the reciprocal of number is just flipping it the other way up. And we may need to do that, or we will need to do that quite a lot. So that's a useful button to be able to know. That's the 1 over x button. Now the second function or button on that we won't be using. That's to do with statistics. Frequency, not the frequency we're used to, but a statistical measure. The next button along, x squared, we will be using that. X squared, I think we've said, a number is squared if it's times by itself. And you may say, well, hang on a second, we don't need that button because we've got the y to the x button. Why don't I simply use that but use 2 for squared, y to the x? So for example, if I want to find 5 squared, I know 5 squared is 25 because 5 times 5 is 25. So 5 squared is equal to 5 times 5 is equal to 25. So I can do the keystrokes here. I can go 5 y to the x 5. I beg your pardon. I can do 5 y to the x 2 equals 25. Those keystrokes again. I can say 5 y to the x 2 is equal to 25. And looking at what happens in the registers, I put in initially 5, and then I press the y to the x button. That moves that 5 up. That's the x register. That moves the 5, copies the 5 into the y, and then I type in a 2, and I press equals, and it gives 25, and everything moves up 1. So, why do I need the x squared button? Well, it's simply a matter of convenience. We more often square things than we cube them or raise them to any other power, 4, 5, etc. So, for convenience then, if I want to do 5 squared, I can just simply press 5x squared. And it gives me the answer straight away. If I want to do 10 squared, 10 x squared. If I want to do 2.3 squared, 2.3 x squared is 5.29. So let's have a quick look at that one. I've done 2.3 squared is equal to 2.3 times itself. So if I did it by long division, long multiplication, 3 3s are 9, 3 2s are 6, and naught in, 2 3s are 6, 2 2s are 4, add them up, 9, 2 6s are 12, 4 is 5. How many decimal places there? 2, 1, 2, 5.29, which is indeed what I've got on the calculator. I can also do that by putting in 2.3 y to the x 2 equals, and I get the same answer. But it's more convenient with the x squared button. Let's look at the next button across. So above x squared, you've got x bar, which is another statistical one. It means the mean. So this calculator will allow you to put a list of values in and get things like the frequency of a number turning up and also the mean. But we certainly do not have to do that. The next button along is root x. Now that means the square root of x. With the root sign, if the root sign is written thus, it's assumed to be the square root. So root 10, or let's say root 100 and make it simple for myself, is equal to 10. In other words, 10 times 10 is equal to 100. That is identical to writing this down. A small little 2 there, and 100 is equal to 10. So if the root sign is there without any little number in there, any little integer, it's assumed to be square root. And again, you would say to me, well, I don't need that because above the y to the x button, I've got x root y. So I can already do that. I can already say, what is the square root of 100? I put in 100. Second function, x root y, 2 equals, and it gives me 10. But because square root is so often encountered, I can put in 100 and just go straight to the square root button, and voila, it gives me 10. So the square root then of, let's say, 25, I press square root button, I get 5. Because 5 times 5 is 25. So above the square root button is sigma x to the n minus 1. That's another statistical measure, as is the one above the divide sign, so we don't need that. Now let's have a quick look at the next row. This one here, there's a sigma sign, that's the capital sigma, Greek letter sigma, which means sum. And this button can do sum minus and sum plus. Okay, those two again I think are for stats. The next number along, the next key along EE, is one that we do need to be able to use. So now it might be worth concentrating a little bit, because this is a fairly crucial part of what we'll be doing with this calculator. After you switch it on, or you switch it off, you switch it on, you can see the display is just a single 0 with nothing else in it. We talked in the intermediate course about using using engineering notation, and if you recall, we said that engineers like to use multiples of 3 to give multiples and submultiples for the units. So, for example, if we have 1 of something, maybe a volt, then we could say millivolts are 10 to the minus 3, microvolts are 10 to the minus 6. In other words, a thousandth and a millionth of a volt. And then going the other way, up from 1 volt, we could say a kilovolt is 10 to the 3, in other words, 1,000 volts, and megavolts are 10 to the 6, which is a million volts. Now, these multiples going up in 3, 6, and minus 3, minus 6, and on further to minus 9, minus 12, etc. We call that engineering notation, because it's very handy to have commonly used names like micro line up with minus 6. We don't use ones like, for example, centi very often. We use it for centimeters, but apart from that, not very often, which is 10 to the minus 2. So as engineers, electronics engineers, radio ham engineers, we use these multiples of 3 very often. So it's handy if we can get our calculator into that correct mode. And the way we do this is simply by pressing, after starting it up, if you look at the 4, 5, 6 row, you will see flow, which means FLOW, means flowing decimal point, scientific or engineering. Now, if you look at a calculation now, if I do a calculation of 1,000 times 3, and I press equals, oops, I've made a mistake there, 1,000 times 3 equals, you will see I get 3,000. If I say 1,001 times 3, I will get 3,003. If I go to engineering notation by pressing second function eng, the display changes to 3.003 times 10 to the 3. And so it's gone into the notation that I will feel comfortable with as I move forward. Let's have a quick look at what we did there. When we were in flow, because flow is the default switch on setting for the calculator, if I say 1,000 times 3, I will get 3,000. So if I said 1,000 volts times 3, it would give me 3,000 volts. That's fine. But actually, I would like to express that, if I was in engineering notation, as 3 times 10 to the 3 volts. In other words, 3 kilovolts. So if I press second function, and then above the 6 key, you will see eng. The display changes to this, 3.003 3. Oh, sorry. Well, let me do that calculation again. It was 1,000 times 3. Okay, it will give you 3. I've made an error there. It will give you 3, and then it'll give you 0, 3, and that's shown there on the display. And what does it mean? That means 3 times 10 to the 3. Now the calculator doesn't show the times 10 to the, it just shows that bit there. So when you're in engineering notation, or indeed in scientific notation, and you see the small little 03 up there, okay, that reads as 3 times 10 to the 3. Now if you wanted to go back and see how many volts it was in flow notation, you'd simply press second function, flow, and it goes back to 3000. If I said 10,000 volts, for example, times 3 equals, that would give me 30,000 volts. Let's have a look at this one. I'm in flow. I know that because I haven't got any indices in the top right. So if I say 3 times 10,000, it gives me 30,000. And that's the display you see in flow. If I now go to second function engineering, I'm now in engineering notation, and it gives me 30 and a little 03. In other words, 30 times 10 to the 3 volts, which I would interpret as being 30 kilovolts. Now if I went to scientific notation, second function 5, it gives me 3 times 10 to the 4. It's the same. The values are the same for flow, engineering and scientific. They're all saying exactly the same thing. They're just saying it in a different way and for a different audience. A scientist might be very comfortable saying, oh, it's 3 times 10 to the 4 volts. Whereas an engineer will think in terms of kilovolts, millivolts, volts, etc. and will want this multiple of 3. So with your calculator then, if you switch to engineering notation, okay, second function engineering, which is above the 6, you will see the little ENG in the top of the display. The ENG there. And your answers will be arranged such that this indice here will always be a multiple of 3. And the digits here will be arranged to give the closest value. In other words, it'll say 30 kilovolts rather than 3, is that heptavolts or something? I don't know. 3 times 10 to the 4 volts. Now you don't have to do this when you switch your calculator on. You can switch your calculator on. If it's off, for example, and you switch it on, it'll start up in flow. And if you forget to put it into engineering and you start to do your sums by saying, for example, 6,000 times, I don't know, 23, and that's how many volts it is, or how many hertz it is, or whatever, and you want to have it in engineering notation, simply just go to engineering notation. If you want to know it as an absolute number in flow format, simply go back to flow. So that figure that we arrived at just a minute ago in engineering notation is 138 kilovolts or kilohertz or whatever units we're working in. So that one pretty well covers the different types there in 4, 5, and 6 of the screen display, and you'll find that you're going to be using second function engineering quite a lot during your calculations. Going on a little bit, I'm looking to see if there's anything I need to have a look at here. No. Flow, scientific and engineering, we've explained. There's an x cubed above the 1. I don't think we'll necessarily need that. It may come up. Again, you'd say, well, why have you got an x cubed if you've got a y to the x? I suppose x cubed, it does save you a keystroke by saying second function x cubed rather than having to use this, perhaps. Percent, that's the usual percent button for using for markups and stuff like that. Always a bit of a trap with these, but we won't be using those, I don't think, anyway. X factorial, we won't be using. Factorial simply means multiplying every number below it. So, for example, best illustrated with an example. 5 factorial is 5 times 4 times 3 times 2 times 1. So that's 5 4 is 20. 80, I think that'll be 160. So if we press 5, second function, x factorial, 120 comes up. And as you notice, as I'm in engineering notation, it's come up as 120, 0, 0. So that means anything to the power 0 is 1. So when we look at those, I think this may be, by the way, you will not need to use factorial for anything that we do. But let's have a look at when we say, for example, let's say we have 1 volt, and then we have at 1 millivolt, we say 1 times 10 to the minus 3 volts, 1 millivolts, 1 millivolt. And then 1 kilovolt would be 1 times 10 to the 3, which is, that's 10 to the minus 3, this is 10 to the 3, which is equal to 1 kilovolt. Now, that is the same as saying 1 times 10 to the 0, because anything to the power 0 is 1. So if you see in your display 0, 0, it just means just what's on the display, the power 10 to the 0, times 1 in other words. So looking further on then, we've got the percent, the factorial, which we've discussed, the cube root of x, which is the opposite of x to the 3 there. I mean, again, you would say, well, you've got x root y. Why use the cube root? I think it's just to for convenience. And there's a button here, fix. Now, that one we won't be using, but it does fix the decimal places. And you might find yourself in it. If I press second function fix 3, then my display is limited to 3 decimal places afterwards. So, for example, if I put in pi, Okay, and I put second function fix 6, you can see it displays pi to 6 decimal places. If I press off and on, I don't start in fix, so the pi comes up as the full precision that the calculator, the full number of digits that the calculator is able to display. But if I wanted to reduce the size of that to just 2 decimal places, I would say second function fix 2 rather, and now it's just saying 3.14. So fix isn't one that we will probably use. You can do if you like. We don't have to be terribly accurate in the advanced certificate. We're looking for the right answer, not huge precision. So you might like to, for example, in certain circumstances, fix it to 4 decimal places because it'll do the rounding for you automatically. And then here at the bottom, finally, another very important button. And the button is called or noted as plus swapping with minus. So it looks like this. Sorry, I've made a mistake. Getting on in the evening, that's a plus, not an X. I said it was an X, but it isn't. It's a plus swapping with a minus. So, plus swapping with a minus, this is simply changing the sign of whichever part of the display you're in. So what do I mean by that? If I switch it off, switch it on, if I put in 5, but I want minus 5, I put in 5 and I press the change sign button. We call that the change sign button. So because I'm in the main part of the display here, then it says minus 5. If I press it again, it reverts to plus 5. If I'm in engineering notation, or in engineering format, and I put in, let's say, 136 millivolts, okay? Now, I may not have explained the EE button at this stage, so perhaps I need to go back to that, or it's a good opportunity to do that. I press in the EE, and I put in 3, for example. I've now entered 136 kilovolts, so let's have a look at the keystrokes for that. So to enter 136 kilovolts, I would enter in 136, okay, EE 3. In other words, 136 times 10 to the 3. And that would look like this. 136 in the display, and up here 0.3. If I wanted to enter in minus 136 volts, kilovolts rather, I would go in 136, change sign, and then EE 3. So now I would put in I put in 136, change sign, and then EE 3. And that would give me minus 136 kilovolts. If I wanted to put in 136 millivolts, I would do it like this. You can see I'm in engineering notation. You can see that there's a little ENG written there. So I would put in 136 EE3, but that's actually given me kilovolts. So I do the change sign business there, and the 0.3 becomes minus 3 there, because I'm entering it at that part of the calculation. I've just entered the 0.3, and I make it minus by pressing the plus minus key at the bottom. So if we have a look at that then, we've got, how do we enter 136 millivolts? We enter it in as 136 EE 3, change sign. That's a single key. Not very well drawn, but it's the one that's at the bottom, on the bottom row here that I'm pointing to. I'm not pointing to it very well. Here we go. There's the one there at the bottom right of the calculator. And that gives us in the display, it gives us 136 minus 0.3. In other words, 136 times 10 to the minus 3. 436 millivolts. So that one pretty well sums that up. I don't now have the opportunity, I don't think, to be able to change it to minus 136 millivolts. Maybe if I press the equal sign, yes I can. I can press the equal sign and now I can change that if necessary if I'd neglected to do it before. But if it was minus 136 millivolts, I would normally go like this. 136, change sign, EE, 3, change sign. And now I've got it. So that pretty well sums up, for this video, the main functions of the calculator. I know it's been a bit long, so I'll sign off with this video at the moment, and soon I will do another video where we actually go through the formula sheet that's given to you, and we'll have a look at some practical examples using the calculator for those formulae. So, thank you very much.